Hello everyone. In this series of videos, I will solve all the physics questions that appeared in previous year NEET exams. In this video, I am going to solve problems from NEET 2023. And this is the first part. So let's solve our first problem, which is the ratio of radius of gyration of a solid sphere of mass M and radius R about its own axis to the radius of gyration of the thin hollow sphere of same mass and radius about its axis is, and 4 options are given. Now to solve this problem, we need to know the formula for the radius of gyration. So in mechanics, the radius of gyration about an axis of rotation is defined as k equals to square root of capital I by capital M. Here capital I is the moment of inertia of the body about the same axis of rotation and capital M is the mass of the object. Therefore, from the above expression we can say that radius of gyration is proportional to square root of moment of inertia. Now if you denote the radius of gyration for solid sphere and the hollow sphere by Ks and Kh, then the ratio Ks over Kh will be equals to square root of Is over Ih. Here Is and Ih are the moment of inertia for solid sphere and hollow sphere. And these are the two quantities we need to know to calculate the ratio of radius of gyration. Now the moment of inertia for solid sphere is given by 2 over 5 mr square and the moment of inertia for hollow sphere is given by 2/3 mr square. Therefore, the ratio of radius of gyration Ks over Kh will be equals to square root of 2 over 5 mr square times 1 over 2/3 mr square, which is equals to square root of 3 over 5, or this can be written as square root of 3 is to square root of 5. So this should be the correct answer, and all the answers given in the options are false. Now next solve our next problem. Our next problem is the work function of cesium, potassium and sodium are 2.14 electron volt, 2.30 electron volt and 2.75 electron volt respectively. If incident electromagnetic radiation has an incident energy of 2.20 electron volt, which of these photosensitive surfaces may emit photoelectrons? And 4 options are given. So according to the questions, the work function of cesium, potassium and sodium are given, which are 2.14, 2.30 and 2.75. Now the energy of the incident radiation is given by 2.20 electron volt. Now according to the theory of photoelectric effect, electrons will emit from the photosensitive surface if its work function is less than the energy of incident radiation. And from the given data, as we can see, the work function for cesium is less than the energy of incident radiation. So option D will be the correct answer. That is, cesium only emit the photoelectrons when an incident radiation of energy 2.20 electron volt will fall on it. Now let's solve our next problem. The amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly, and given that surface tension of soap solution is 0.03 Newton per meter. And these are the 4 options. So according to the question, the radius of the soap bubble is given, which is 2 cm, and the surface tension of the soap solution is 0.03 Newton per meter. Therefore, initial surface area of soap bubble is 0 and final surface area of the soap bubble is 2 times 4 pi r square. Here the factor 2 comes as soap bubble has 2 surfaces. Therefore, we can say increase in surface area is equals to 2 times 4 pi r square. Now we know that the amount of energy required is equals to surface tension times increase in surface area, which is equals to T times 2 times 4 pi r square. Now if you put the values for capital T and small r in same unit, then you will get the final answer, which is 3.01 times 10 to the power minus 4 joule. Therefore, option B is the correct answer. Our next problem is resistance of a carbon resistor determined from color code is 22,000 plus minus 5%. The color of third band must be, and four options are given: green, orange, yellow and red. So the given resistance is 22,000 plus minus 5% ohm. Here 5% is the tolerance, and according to 4 band color code, the first band, the value of the first band is 2, second band is 2 and multiplier is 1 kilo ohm. Then you will get this resistance. Therefore, the color of the first band must be red, the color of the second band must be red and the third band should be orange. So our correct answer is option B, orange. Now let's go to our next problem. Our next problem is, in a series LCR circuit, the inductance L is 10 millihenry, capacitance is 1 microfarad and resistance R is 100 ohm. The frequency at which resonance occurs is, four options are given. So given quantities are L, C and R. Now the frequency at which resonance will occur is given by F equals to 1 over 2 pi times 1 over square root of LC. Now if you put the value of L and C in the same unit, then you will get the final result 1.59 times 10 to the power 3 Hertz, or this is equals to 1.59 kilohertz. So option C is the correct answer. Now let's solve our next problem. In a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 times 10 to the power 10 Hz and amplitude 48 volt per meter. Then the amplitude of oscillating magnetic field is, and it is given that speed of light in free space is 3 times 10 to the power 8 meter per second. And these are the four options. So it is given that the frequency of oscillation is 2 times 10 to the power 10 Hz, the magnitude of the electric field is 48 volt per meter and speed of light is 3 times 10 to the power 8 meter per second. Now we know that the amplitude of magnetic field is given by the ratio E over C. Now if you put the values for E and C, then you will get B is equals to 1.6 10 to the power minus 7 Tesla. Therefore option B is the correct answer. Our next problem is, given below are two statements. Statement 1. Photovoltaic device can convert optical radiation into electricity. Statement 2. Zener diode is designed to operate under reverse bias in breakdown region. In the light of the above statements, choose the most appropriate answer from the options given below. And these are the four options. Here both the statements are correct. Therefore, option D should be the correct answer. Both statement 1 and statement 2 are correct. Our next problem is, the errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply are, and these are the four options: personal error, least count error, random errors, instrumental errors. Now in this question, the most important phrase is unpredictable fluctuations. Unknown and unpredictable changes in the experiment causes random errors. Therefore, option C should be the correct answer. If closed integration over E dot ds equals to 0 over a surface, then which of these following are true? The correct answer is option D. The number of flux lines entering the surface must be equal to the number of flux lines leaving it. Our next problem is, if the galvanometer capital G doesn't show any deflection in the circuit shown, the value of R is given by, and these are the four options: 50 ohm, 100 ohm, 400 ohm, 200 ohm. So according to the question, the galvanometer G doesn't show any deflection in the circuit, which means that no current is flowing through the galvanometer. Therefore, the equivalent circuit diagram will be this. So we can say that the voltage drop across the resistance R is 2 volt. Now the current through the resistance R is 10 minus 2 over 400, which is equals to 1 over 50 ampere, and this is also equal to the current through the circuit. Therefore, the value of resistance R is 100 ohm. So, option B is the correct answer. Our next problem is an AC source is connected to a capacitor C. Due to decrease in its operating frequency, displacement current increases, displacement current decreases, capacitive reactance remains constant, capacitive reactance decreases. We know that the relationship between operating frequency and capacitive reactance is given by 1 over 2 pi fc. Therefore, from this expression we can say that if the frequency decreases, then capacitive reactance will increase. And as capacitive reactance increases, the conduction current will decrease. But in case of capacitor, displacement current is equals to conduction current. Therefore, with the decrease in operating frequency, the displacement current will decrease. So, option B is the correct answer. Our next problem is the minimum wavelength of X-rays produced by an electron accelerated through a potential difference of V volts is proportional to 1 over V, 1 over square root of V, V square, square root of V. We know that when an electron is accelerated through a potential difference of V volts, then EV is equals to h nu, which is equals to hc over lambda. Therefore, we can write lambda is equals to hc over EV. Therefore, lambda is proportional to 1 over V. So, option A is the correct answer. Now, let's go to our next problem. The Venturi meter works on Bernoulli's principle, the principle of parallax axis, the principle of perpendicular axis, Huygens principle. The correct answer is option A. Venturi meter works on Bernoulli's principle. A full wave rectifier circuit consists of two PN junction diodes, a center tap transformer, capacitor, and a load resistance. Which of these components remove the AC ripple from the rectifier output? And these are the four options: PN junction diodes, capacitor, load resistance, a center tap transformer. The correct answer is to reduce the ripples in rectifier circuit, a bypass capacitor filter is used. Therefore, correct answer is option B, capacitor. Our next problem is a metal wire has mass 0.4 plus minus 0.002 gram, radius 0.3 plus minus 0.001 millimeter, and length 5 plus minus 0.02 centimeter. The maximum possible percentage error in the measurement of density will nearly be, and these are the four options given. So, according to the question, mass is given 0.4 plus minus 0.002 gram. So, this can be written as m plus minus delta m. Here, delta m is the error in the measurement of mass. Similarly, for radius, we can write it as r plus delta r, and for length, it can be written as l plus delta l. Now, we know that the density is given by rho is equals to m over v. Now, for the metal wire, the volume is given by pi r square L. Therefore, we can write density equals to m over pi r square L. Now, to calculate maximum possible percentage error in the measurement of density, first we have to take the logarithm on both sides of the equation, which gives log of rho equals to log of m minus log of pi minus 2 times log of r minus log of capital L. Now, we have to take derivative on both sides of the equation, which gives delta rho over rho equals to delta m over m minus 0. Pi is a constant, that's why derivative of log of pi will give 0, minus 2 times delta r over r minus delta L over L. Therefore, maximum percentage error in the measurement of the density is delta rho over rho times 100, which is mod of delta m over m times 100 plus 2 times delta r over r times 100 plus delta L over L times 100. Now, if you put all the values for delta m, delta r and delta L, then the final answer will be 1.6%. Therefore, the correct answer is option B, 1.6%. Now, let's go to our next problem. For Young's double slit experiment, two statements are given. Statement 1. If screen is moved away from the plane of slits, angular separation of the fringes remains constant. Statement 2. If the monochromatic source is replaced by another monochromatic source of larger wavelength, the angular separation of fringes decreases. In the light of the above statement, choose the correct answer from the options given below. So these are the four options. Now in Young's double slit experiment, the angular separation is given by theta equals to lambda over small d. Here lambda is the wavelength of the light and d is the separation between the slits. Therefore, angular separation is independent of the distance between the screen and the plane of the slit. So, angular separation will not change if the screen is moved away from the plane of slits. So, statement 1 is correct. Again, angular separation is directly proportional to the wavelength of the slit. So, for a light of larger wavelength, the angular separation will increase. Therefore, statement 2 is incorrect. Therefore, the correct answer will be option B. Statement 1 is true, but statement 2 is false. Our last problem in this first part of the video is the potential energy of a long spring when stretched by 2 cm is capital U. If the spring is stretched by 8 cm, potential energy stored in it will be, and these are the four options. We know that the potential energy for a spring is given by capital U equals to half times kx square. Now let U prime be the potential energy when the spring is stretched by 8 cm. Then we can write capital U prime over U is equals to x prime square by x square, which is equals to 8 square over 2 square times U. Therefore, capital U prime is equals to 16U. Therefore, option C is the correct answer.